Hi everyone, Miss Pellegrino here. In this video, we're going to be talking a little bit about zeros with decimals. Now, we started talking about this last week when we talked about equivalent decimals. Equivalent decimals are two decimals that, even though they're written a little differently, actually represent the same amount. However, we seemed a little bit confused about zeros and decimals, so I wanted to make this video to talk a little bit more about that. So let's start out with this decimal here. In this decimal, we have 0.3. Now, normally we would read a decimal by starting with our whole numbers, but in this case, we don't have anything here. We just have 0. So we don't even have to say anything here. We would just say 3/10. So in this first decimal, we're showing 3/10. And as we saw in our last video, we can show that using a picture by taking a whole, splitting it into tenths, and coloring in 3 of those to show 3/10 colored in. Next, let's look at a similar decimal. So in this case, I'm going to look at 0.30. So here we have 30 hundredths. So now let's look at how we could show that as a picture. Well, going place by place, we have 3/10. So I would show 3/10 by showing that there's 10 pieces and 3 of them are colored in. I also have 0 hundredths. So I've put a hundredths picture here, but no pieces are colored in. Now, when I look at these two, we notice that the tenths are the same. They both have 3/10. This one has 0 hundredths colored in. Would this first decimal have any hundredths colored in either? I can see that there's nothing in that hundredths place, and that would mean that there are no hundredths colored in on its chart either. Because there are no hundredths, we could also just say that there are 0. So even though this decimal, 30 hundredths, specifies that there are 0 hundredths, and this one did not, we can tell that there are no hundredths in either one of them, because if there were any hundredths being colored in, they would have said so. So both of these are actually the same decimal, even though one has a 0 and one does not, because they both show 3/10 and nothing else. Now, the other way you can see zeros and decimals might look something like this. So here I have that same 3/10, and on the bottom I've now shown 3 hundredths. So in this case, the 0 comes before the 3 instead of after. How does that change its value? Well, let's think about it using a picture. This first decimal, 3/10, would look something like this if we were to draw it out, where we have a whole that's split into 10 pieces and 3 are colored in. The second decimal has 3 hundredths. So I could represent that by saying, okay, well, there are 0 tenths, so I'm going to go ahead and put tenths here, but none are colored in, and 3 hundredths. So I have my hundredths chart, and only 3 of those little boxes are colored in. So we can see here that the same amount is not colored in. These are very different decimals. So to summarize, if there are zeros at the end of a decimal, they don't really affect its value. Think about this 3/10 and this 30 hundredths. Both of them showed the same picture when we drew it out. They both had 3/10 and no hundredths. Zeros before the last digit of a decimal do affect its value. On the other hand, zeros before the last digit of a decimal do affect its value. So for this part, you can think about these two decimals here. 3/10 looked like this, but 3 hundredths had a much smaller piece colored in. Keeping in mind these rules, can you determine if these decimals are the same or not? Remember, zeros after the last digit don't change the decimal's value, but zeros before the last digit do change it. Go ahead and pause the video and try these out yourself. All right, let's see if you got them. These first two decimals are 6/10 and 6 hundredths. Well, that 6 is in a different place in both of those decimals, so they're definitely not the same. Over here we have 1 and 20 hundredths and 1 and 2/10. In both of these decimals, they have a 1 in the ones place, a 2 in the tenths place, and one of them has a 0 in the hundredths place, and the other has nothing in the hundredths place. Well, 0 and nothing are the same thing. They both represent nothing there. So these are the same. Remember that any zeros after the last digit don't change the decimal's value. These two are the same. Our next example has 7 and 21 hundredths and 7 and 21 thousandths. So here we have a 2 in the tens place and a 0 in the tenths place. Because these digits are different, these decimals are not the same. For our next one, we have 2/10 and 2,010 thousandths. Remember that any zeros after that last digit don't actually change the value of the decimal, because both of these decimals have a 2 in the tenths place and then nothing else after it. So these two are the same. 54 hundredths and 5 and 4/10. We can look at these by comparing their places. In the ones place, this first one has a 0, and this second number has a 5. Obviously, these are not the same because 0 and 5 are not the same. So these are not the same decimal. For our last one, we have 7/10 and 70 hundredths. 7/10 has a 7 in my tenths place. 70 hundredths also has a 7 in my tenths place. 70 hundredths has a 0 in the hundredths place, and 7/10, well, it has nothing in the hundredths place. Nothing and 0 are the same thing, so we could say that these two are equivalent. Keep these rules in mind as you work on your decimals for today. Good luck, everyone, and I'll see you around.